Dear friends, welcome back to my video lecture series. In this video, I will explain the second method, that is the Crank-Nicholson method, to find the solution of the parabolic kind equation, particularly if you want to say one-dimensional heat equation. Okay, shall we go to the problem now? I will explain the Crank-Nicholson concept first, and then we will solve the related problems in this topic. Right. To solve the parabolic equation, Crank-Nicholson is going to consider the boundary condition and the initial condition to solve u double x equivalent to A into ut. That is potential heat equation. Right. At uij, he is fixing the point uij, he is finding u double x, and at the point ui comma j plus 1, he is going to fix u double x. He is going to take the average of that is the difference only compare the Bender-Smith method. Then he is getting this one. The equation will be like this. Then for ut, suffix t will be ui comma j plus 1 minus uij divided by k. Is applying, substituting there. Then if you are substituting in that equation, in that one-dimensional heat equation, they are going to give that a lambda is equivalent to k divided by a h square, because if you are taking this to the right, k to the left hand side, k divided by h, a h square, it will come like that. That's why they are going to simplify that. They are going to give the substitution by replace this by lambda, right? Then he will get this equation alter form, another form. If you're taking average like two, can if you're taking LCM both sides, so they will get this equation. This equation is nothing but Crank-Nicholson difference scheme. Here also, for simplicity, he is going to consider one value. This is what the formula for Crank-Nicholson difference scheme. For simple, if you want to simplify, for simplicity, he'll consider one value. That value will be choosing lambda equal to 1, because Crank-Nicholson scheme will converge for all values of lambda. That is the important thing. It will take place for MCQs. Right. So that's why particularly they are choosing lambda equal to 1, which implies k lambda value is what? K by ah square. Then what about k? K equal to ah square. So in Crank-Nicholson method, the formula for k is a h square. What about in Bender-Smith method? So do you remember? K is equivalent to a h square divided by 2, half of the Crank-Nicholson method. Try to remember like that, then only you won't do any mistakes. Got it? Right. Then the previous one will be will reduce it to this one, ui comma j plus 1 equivalent to 1 by 4. I mean, average of this value, this value, this value, this value. This value I will give you using diagrammatic representation. Then only easily you can understand the concept. That's it. This is what the simplified Crank-Nicholson scheme, particularly for lambda equal to 1. Right. So look at that. Uh, I have to find this value a, and what will be left plus right, left most top, this value, and the right topmost will this value. So this four value, average of this four values only. So it will be easy to understand here also. Clear? If I want to find this value, this one I am going to find this plus this plus this divided by 4, average of the four values. That's it, guys. It's so simple. So A equivalent to average of B, C, D, B, C, D, E. Clear? Right. I will explain this concept with an example, then only it will be easy to understand. I specified it. Solve by Crank-Nicholson method. U double x equivalent to ut. It is one dimensional equation. That is another clue. Boundary condition, one initial condition. For two time steps, most of you will be confused. It is not the meaning for t equal to 2. T equal to 2 means up to 2 seconds they will mention. Two time step, it's nothing but in the x-axis, x direction 0, t direction also 0. This is initial time step, first time step, and the second time step. That's what they mean. Not 1 and 2, the difference will be varied. So this is initial time step, first time step, second time step. This is what the meaning. Up to 2 time steps we have to find here, not up to t equal to 2. It is wrong. Okay, clear? Right. Now come to the problem. From the given partial differential equation, choose your A and H value. They didn't specify, but with the help of the given initial and the boundary condition, we can find the value of the H range. H varies from 0, X varies from 0 to 1 first. 0 to 1. In 0 to 1, whatever the difference we can take, either we can take zero point 0.2 or 0.25, because if you are taking 0.5, 0.5, 1, immediately it will complete. It won't be workable for, if they're asking in 8 mark or because in some other 10 mark question, it won't be workable for that. That's why we can consider h is equivalent to zero point 0.2 or h is equivalent to 0.25. That is h is equivalent to 1 by 4. In that way also we can consider here. Right. Now let's h equivalent to 1 by 4. Then what about k formula? K equivalent to a into h square. A value 1, h value 1 by 4 whole square. It will be 1 by 16. So k value is 1 by 16. If you want, you can write this as in decimals also. Here I have written as fraction 1 by 1 upon 16. If you want to write in decimals, divide 1 by 16, use calculator. We can write in decimals also. Right. We have to find the two time steps only, not a time t equal to 2. That is an important thing. Right. So Smith simplified, sorry, Crank-Nicholson simplified form is this. Then u of 0 comma t, u of 1 comma t, u of x comma 0 equal to 0. In x direction, we assumed that h is equivalent to 1 by 4, that is 0.25. In t direction, we found k equal to 1 by 16. So look at that, x varies from 0 to x varies from 0 to 1. So 0, 0.25, 0.5, 0.75, 1. What about in h direction? Difference is 1 by 16, 0, 1 by 16. That's it. And then it will be 2 by 16. So initial time step, first time step, this is a second time step. So up to 2 time steps only they asked to solve. Right. Now come to the boundary condition. What are the boundary conditions are there? U of 1 comma t. Where is 1? X equal to 1. X equal to 1 will be this position. U of 1 comma t equal to t. Give the value. T equal to 0 will be 0. D equal to 1 by 16. Replace by here, it will be 1 by 16. T equal to 2 by 16, it will be 2 by 16. So it will be same. What is the next boundary condition? U of 0 comma t equal to 0. At x equal to 0, u value is 0. This boundary condition 0. Then what about the third one? U of x comma 0. T value 0. Where it will be? In x-axis. T value 0 in x-axis. So will be 0, 0, 0. That's it. So how can I find this one? Let us consider this value u1, u2, u3. After completed, we can find u4, u5, u6. These are all the interior points we have to find now. So okay, fine. Now I have to find u1. How can I find this plus this plus this divided by 4, average of that 4 values? Yeah. So u1 equivalent to 1 by 4 into 0 plus u2 plus 0 plus 0. So what I can get? 4u1. Take 4 this side. 4u1. This u2 is in the right hand side. Take to the left hand side. Minus u2 equal to 0. This is one equation. Similarly, we have to proceed for u2. What about u2? u2 is equivalent to 1 by 4 into u1 plus u3 plus 0 plus 0. Yeah. So for u2, we have to find. So it will be this plus this plus this. In that way, we have to proceed here. So if you are solving the first one, we will get 4u1 minus u2 equal to 0. If you are proceeding for u2, as I told you already, 1 by 4 plus u 0 plus 0 plus u1 plus u3, which implies u1, take everything to the left hand side because we are going to solve for three unknowns. What are the three unknowns we are going to solve here? For the first row, first line, first row we have to complete for here, then only we can proceed for u4 or u5, u6. First time step you have to complete, then only you have to move to the second time steps. Right. Now the average of u1 is average of the 4 points, you will get one equation. Similarly, u2 is average of that 4 points. Average means what? If you want to find this value, this plus this and this plus this divided by 4. Am I right? Right. So next equation. Similarly, if we are proceeding for u3, you will get another equation. So if you are solving equation 2, 3, 4, keep it in decimal place for three unknowns using calculator, we can get u1 is this, u2 is this, u3 is this. Now if we found u1, u2, u3, we have to find u4, u5, u6. Two time steps. u4 value. What is the value of u4? It will be 1 by 4 into 0 plus 0 plus u2 plus u5. Then write it in the equation format. Now we are going to solve for first we have completed u1, u2, u3. Now we are going to proceed for u4, u5, u6. Left hand side here it is 0, 0. Here it is 1 by 16, 2 by 16. Clear? So if you want to find u4, what will be 0, left first, 0 plus u5 plus 0 plus u2. In that way we have to move. So we are going to solve for three unknowns, u4, u5, u6 now, right? Similarly, proceed for u5, we can get one equation, and proceed for u6, we will get another equation. Solving 5, 6, 7 using three unknowns. What are the three unknowns? u4, u5, u6. Here u4 is there, u5 is there, u5 is not there. That coefficient you have to give 0 in your calculator. Do not leave simply, right? So solving this three equation, we can get u4 values this, u5 values this, u6 values this. That's it. This is the way to find the interior lattice point temperature distribution using Crank-Nicholson scheme. Right. I have chosen one more problem. U double x equivalent to 16 ut. Crank-Nicholson only they specified particularly boundary condition and the initial condition. And particularly they have given h is equivalent to 1 by 4. And one time step. One time step means what? Initial time, and then the next step will be first time step. One time step or first time step. Not up to t equal to 1. Clear? Right. So take the problem, identify a from that, a equal to 16, then h equal to 1 by 4 they have given, then k equal to a h square is equivalent to a value 16, 1 by 4 whole square, it will be 1, k value 1. Clear? Right. Use Crank-Nicholson scheme. That scheme represents what? This diagrammatic representation. Do not forget this diagrammatic representation. If you want to find this value a, b plus c, e plus d by 4. Clear? Right. So the boundary conditions are x direction, h is equivalent to 0.25. We found k value is equal to 1. It is in t direction. Now draw this u of 0 comma t. X equal to at x equal to 0, u value 0. So 0, not this one. That 0, not it. This 0, 0. At uh, what will be t equal to 0. T equal to 0 also u value will be 0. Where is t equal to 0, 0 line? This is t equal to 0 line. So 0, 0, 0. What is the next boundary condition? X equal to 1. X equal to 1 will be this line. What will be there? It will be 100 t. Qx equal to, I mean t equal to 0 here, it will be 0. Qt equal to 1, it will be 100. Clear? This is the way to fill the boundary conditions. Right. Look at that. That's it. Now we have to find u1, u2, u3. How to find u1? That formula. This plus this plus this divided by 4. So u1 equivalent to 1 by 4 into 0 plus u2 plus 0 plus 0. So 4u1 minus u2 equal to 0. This is one equation. If you want to find u2, what will be? This plus this plus this divided by 4. So what will get for you? For u2 is equivalent to 1 by 4 into u1 plus u3 plus 0 plus 0. So what will get? 4u2, that u1 and u3 are on that side, take to the left hand side, or you can take 4u2 to that side. That also you can do. So then if it will be minus 4u2. u1 minus 4u2 plus u3 equal to 0. This is another equation. If you want to find u3, then this plus this plus this divided by 4. So I solved it here. For u1 will be this, you'll get from equation. For u2 will be this, for u3 will be this. Solving three equations for three unknowns. What are the three unknowns here? u1, u2, u3 we are solving. So we can get u1 value is 1.7857, u2 value is 7.1428, u3 value is 23.78567. That's it, guys. This is the way we have to get the solution for the one-dimensional heat equation using Crank-Nicholson method. Is it